And as we moved into the latter part of the 20th century, and especially into the early 21st, a massive global shift happened. Environmental consciousness.
Ah, yes. The green wave.
Exactly. And it directly impacted stern tube design and, frankly, the entire maritime industry. This wasn't just about being a good corporate citizen anymore. It became about hard regulation.
Okay, so what were the key drivers there?
Well, key legislative drivers included MARPOL Annex 1. That's part of the big international convention for the prevention of pollution from ships, specifically targeting oil pollution.
Right. MARPOL is huge.
It is. And this was reinforced by stricter national rules like the U.S. EPA's Vessel General Permit, the VGP, back in 2013, and its successor, VITA, the Vessel Incidental Discharge Act.
And what did they demand specifically regarding stern tubes?
These regulations specifically mandated the use of environmentally acceptable lubricants, or EALs.
Like EALs, okay.
These are oils formulated to be non-toxic and biodegradable if they do happen to leak into the sea. Their use became mandatory for oil-to-sea interfaces, like stern tubes, especially for vessels operating in sensitive waters like those of the U.S.
So you either had to use these special, often more expensive oils, or guarantee zero leaks.
That's the crux of it. And the powerful insight here is that these environmental regulations, far from just being a compliance headache, acted as this unprecedented accelerant for engineering innovation.
Right. Necessity is the mother of invention.
Absolutely. It pushed the industry to fundamentally rethink designs that had been standard for decades. The implication was crystal clear. Either eliminate oil discharge entirely or find a way to contain it perfectly.
And this brings us in a really fascinating way, almost full circle, doesn't it?
How so?
Well, with that regulatory push, it's like history repeating itself, but with a high-tech twist. We've seen a resurgence of water-lubricated systems.
Ah, yes. Back to water.
But these aren't your grandfather's lignum vitae bearings.
No. Definitely not. Much more advanced now.
The modern twist involves using advanced composite bearings. These are often thermoset polymers, sometimes elastomer-lined materials. Companies like Thordon Bearings have really pioneered these solutions.
They're a big player.
And the big pro here is undeniable. Zero oil pollution risk, period. They're inherently environmentally compliant because you're using seawater or sometimes conditioned fresh water as the lubricant.
Which also simplifies the whole fluid management side of things. No oil coolers, maybe simpler filtration depending on the system.
True. But there's still considerations, right?
Yeah.
It's not a perfect solution for every ship.
No, there are trade-offs. These systems can still be sensitive to abrasive particles. That sand and silt issue hasn't entirely gone away, so careful water filtration or flushing systems are often needed.
Okay.
And in some specific operating conditions, particularly at very slow speeds, there can sometimes be potential for noise or vibration, sometimes called stiction or stick slip.
Right. So it's a trade-off, but one that offers huge environmental benefits for many types of vessels, especially those operating in sensitive areas.
Indeed. And for those vessels where the robust performance and proven track record of oil-lubricated bearings are still preferred, perhaps for very high loads or specific operational profiles, but where zero discharge is now non-negotiable, another ingenious solution has emerged. Air guard systems, or sometimes called air seals. These are kind of a pragmatic hero in the environmental fight.
Air guard. How does that work? Sounds intriguing.
It essentially gives you the best of both worlds. The concept involves creating a continuous air barrier within the stern tube sealing arrangement itself.
An air barrier?
Yeah. Pressurized air, supplied by a dedicated onboard compressor and control system, is injected into a specific chamber located between the inner oil retaining seals and the outer seawater exclusion seals.
Ah, a space between the seals.
Exactly. This air pressure is maintained just slightly higher than the surrounding seawater pressure. What this does is create an impenetrable buffer. It physically prevents oil from getting out past that barrier, and it also prevents seawater from getting in.
Clever. So if any oil does leak past the inner seals.
It gets captured in this air chamber. It doesn't go into the sea. It's typically drained away automatically and collected for proper disposal ashore. So you get near zero discharge to the environment.
That's brilliant. Which companies make these?
Major manufacturers like Wärtsilä offer their air guard system, and SKF Marine has their air seal. They're prominent providers of this kind of technology.
That's truly clever engineering. It effectively keeps the superior hydrodynamic advantages of oil lubrication while achieving that near zero oil discharge goal.